In an aqueous solution, the oxidation of nitric oxide occurs according to the equation shown here. The reaction is second order in nitric oxide and first order in oxygen. And we're asked first to write the rate law and then determine some other things here. So when it comes to the rate law, again, it has this general form. Rate is equal to K, a rate constant, times the concentration of each of the reactants that are aqueous or gases. So NO is nitric oxide, and it's second order, so we put a power 2 there. And oxygen is another reactant, and it's first order, so we put a 1 here. And water is a liquid here, so it's not aqueous and it's not a gas, so we don't include that in the rate expression here. When something is raised to the first power, we get that same number or value back again, so we could just write the rate equation as NO squared O2. All right, the overall order for this reaction is going to be the sum of the individual orders. So 2 plus 1 is equal to 3. So this reaction is third order overall. Now, we have these other questions that ask us what happens to the rate. That's again the reaction rate, not the rate constant, which is always the same. It's a constant. And C, we're doubling the oxygen concentration. Okay, so to work on these types of questions, an easy thing to do is just plug in 1 for all of the initial concentrations of your chemical reactants. And so this is 1 squared times 1, times K. That's just K. And then see what happens if oxygen is doubled. So let's compare over here. NO is just going to remain the same, so we'll just plug in a fictitious 1 there. And then we want to double 1 molar. So that's going to become 2 molar. Okay, and that's to the first power. So 1 squared is just 1 times 2 times K. That's equal to 2 times K. Okay, so the reaction rate doubles here. Or we could say that the reaction rate increases 2 times. Now we want to do the same thing for part D here. In this situation, we have a couple things that are changing. So again, just to be complete, I'll go ahead and write down our fictitious starting point. If the rates, if the concentration of all of the starting quantities are just 1 here, we'll have the value of K. And then we want to go ahead and change the concentrations of things according to part D. So NO is doubled, so we want to change the 1 to a 2. And O2 is halved, so 1 goes down to 1/2. Okay? So 2 squared is 4 times 1/2. That comes out to be 2 times K. Okay? So you have to watch out for the powers and carry it all out. So here we would say that the rate also increases 2 times. Thanks for watching.